Good morning, students. Welcome back to the session on fundamentals of cloud computing. Today, we will study about distributed computing and parallel computing. So first, we will study about distributed computing. So distributed system is also known as distributed computing. Is a system with multiple components located on different machines that communicate and coordinate actions in order to appear as a single coherent system to the end user. The machines that are a part of distributed system may be computers, physical servers, virtual machine, containers, or any other node that can connect to the network, have local memory, and communicate by passing messages. Distributed computing is a model of computation that is firmly related to distributed systems. It refers to a multiple computer system located at different places, linked together over a network and used to solve higher level computation without having to use an expensive supercomputer. Distributed system is called when collection of various computers seems a single coherent system to its client, then it is called distributed system. According to the definition of the distributed computing system, all the computers are tied together in a network, either a local area network or wide area network, communicating with each other so that different portions of a distributed application runs on different computers from any geographical locations. Every node on distributed computing is autonomous machine. Distributed systems have broken down into two parts, the front end and the back end. Front end is a part of application that the user interact with to determine what information and how to organize it, and it runs on the user computer. The backend is a part of the application that finds and sorts the requested information, runs on a central computer somewhere else. This type of distributed computing is also referred as client-server architecture. It splits up the functioning of application across some separate computers. Grid computing is based on distributed architecture and is the form of distributed computing. It involves large number of computers physically connected to solve a complex problem. There are two general ways that distributed system functions. Each machine works towards the common goal and the end user views result on one cohesive unit. Each machine has its own end user and the distributed system facilitates sharing resource or communication services. So common way of organizing a software to run on distributed system is to separate a function into two parts, client and server. A client is a program that user services that other program provides. The programs that provides these services are called server. The client make a request for a server service and the server performs that service. Server function often require some resource management in which a server synchronize and manage access to the resource and responds to the client request with either data or status information. Different types of distributed systems. The nodes in the distributed systems can be arranged in the form of client-server system or peer-to-peer system. First one, client server system. So client contact the server for data, then format it and display it to the end user. The end user can also make a change from a client side and commit it back to the server to make it permanent. Second one, peer-to-peer system. There are no additional machines used to provide services or manage resources. Responsibilities are uniformly distributed among machines in the system. It is known as peer, which can serve as either client or server. 3-tier. Information about the client is stored in a middle tier rather than on the client to simplify application deployment. This architectural model is most common for web application. N-tier, generally used when an application or server needs to forward requests to additional enterprises services on the network. Distributed systems have endless use cases, a few being electronic banking system, massive multiplayer online games, and sensor networks are some of the examples of distributed system. Advantages of distributed system. All the nodes in the distributed system are connected to each other. So nodes can easily share data with other nodes. More nodes can easily be added to the distributed system. That is, it can be scaled as required. Failure of one node does not lead to the failure of the entire distributed system. Other nodes can still communicate with each other. Resources like printers can be shared with multiple nodes rather than being restricted to just one. Disadvantages of distributed system. It is difficult to provide adequate security in distributed system because the node as well as the connections need to be secured. Some message and data can be lost in the network while moving from one node to another. The database connected to the distributed system is quite complicated and difficult to handle as compared to a single user system. Overloading may occur in the network if all the nodes of the distributed system try to send data at once. Next topic, parallel computing. So before taking to parallel computing, first we will just learn about the serial computing. Computer software were written conventionally for serial computing. This means that to solve a problem, an algorithm divides the problem into smaller instructions. These discrete instructions are then executed on central processing unit of a computer one by one. Only after one instruction is finished, next one starts. Traditionally, serial computing software has been written for a problem is broken into a discrete series of instructions. Instructions are executed sequentially one after another. It executed on a single processor. Only one instructions may execute at a moment in a time. So real life example of this would be people standing in a queue waiting for a movie ticket and there is only one cashier. Cashier is giving ticket one by one to the persons. Complexity of this situation increase when there are two queues and only one cashier. So in short, if we want to say, In this problem, the statement is broken into discrete instructions. Then the instructions are executed one by one. Only one instruction is executed at any moment of time. So we will just could definitely say that the complexity will decrease when there are two queues and two cashier giving tickets to two persons simultaneously. So this is the example of parallel computing. So parallel computing, it is the use of multi-processing element simultaneously for solving any problem. Problems are broken down into instructions and are solved concurrently as each resource which can be applied to workers working at the same time. Parallel computing is a type of computing architecture in which several processors simultaneously execute multiple smaller calculations broken down from an overall larger complex problems. In simple way, if we want to say, so problem is broken down into discrete parts that can be solved concurrently. Each part is further broken down into a series of instructions. Instructions from each part execute simultaneously on different processors, and overall control mechanism is employed here. Why we are using parallel computing? So before going to the task, why we are using parallel computing? So real world data needs more dynamic simulation and modeling, and for achieving the same, the parallel computing is used. Complex large data sets and their management can be organized only using parallel computing approach. It is impractical to implement real-time system using serial computing. So advantages of parallel computing, if you take, it saves time and money as many resources working together and will reduce the time and cut potential costs. It can take advantage of non-local resources when the local resources are finite. Serial computing wastes the potential computing power. Thus, parallel computing makes better work of hardware. So, types of parallelism. Bit level parallelism. It is the form of parallel computing which is based on increasing processor size. It reduces the number of instructions that the system must execute in order to perform a task on large size data. Example, consider an scenario when an 8-bit processor must compute the sum of two 16-bit integers. It must first sum up the 8 lower order bit, then add the 8 higher order bit, thus requiring two instructions to perform the operations. A 16-bit processor can perform the operation with just one instruction. The next one, instruction level parallelism. A processor can only address less than one instruction for each clock cycle phase. These instructions can be reordered and grouped, which are later executed concurrently without affecting the result of the program. Data parallelism. The multiple processor system can execute a single set of instruction. Data parallelism achieved when several processors simultaneously perform the same task on a separate section of the distributed data. Task parallelism. Task parallelism employs the decomposition of a task into subtasks and then allocating each of the subtasks for execution. The processor performs execution of subtasks concurrently. Why use parallel computing? So if you take in a natural world, many complex interrelated events are happening at the same time with a temporal sequence. Compared to serial computing, parallel computing is much better suited for modeling, simulating, and understanding complex real-world phenomena. For example, imagine galaxy information, planetary movements, and climate change. Save time and or money. In theory, throwing more resource at a task will shorten its time to completion with potential cost savings. Parallel computers can be built from cheap commodity components, solve larger or more complex problem, provide concurrency. A single compute resource can only do one thing at a time. Multiple compute resource can do many things simultaneously. Example, collaborative networks provide a global venue where people from around the world can meet and conduct work virtually. Thank you, students.